Alright, so now I got a series of problems that we're going to go over because of the audio difficulties this morning. Alright, so basically we're looking at down here a right triangle with two sides. Whenever they give us two sides, we're going to use regular Pythagorean theorem to get the third side. So 14 squared plus 7 squared would be the square root of 245. Alright, and then this comes out to be 245. And the square root of 245 equals A. Now again, notice 7 goes into both 7 and 14. That means 7 at the very least has got to be in the outside. 7 squared is 49. Goes into 245 5 times. Square root of 49 is 7. So A ends up being 7 root 5. They're both 7 root 5. Why? Well, the angles are congruent. It's an isosceles triangle. Okay, so now we're going to go to this triangle and realize now we have two sides. A leg, which is 13, and a hypotenuse, which is 7 root 5. So to get C, the other leg, C squared plus 13 squared equals 7 root 5 squared. Alright. C squared plus 169 equals 245. Alright. C squared equals 76. And C equals the square root of 76, which when we're done simplifying would be 219. So C is root 19. Alright, now we're going to come over here and use some angles. These are parallel. Alright, so corresponding angles are supplementary. So if that one's 90, it means this whole angle here is 90. 15 and 30 is 45. 45 subtract from 90 makes that 45. That's a right angle up top because they form a linear pair. That's going to be 45, so I got my isosceles right triangle. So if that's 13, E is also 13. Alright, and I got the legs of 13, 13, and D would then be 13 root 2. Alright, now 30, 60, 90, I have a 30, 60, 90 right triangle. 13 root 2 is equal to D. Well, unfortunately, that's my root 3 side. So F root 3 would be 13 root 2. Because remember, we would take whatever the smallest leg is and multiply by root 3. To solve for F, we would divide by root 3. And then we would rationalize. So this is what we're talking about. So now you have to, when the radicals don't match up perfectly with what you got to do. So this becomes 13 root 6 over 3. Alright? So F is 13 root 6 over 3. The hypotenuse of a 30, 60, 90 is double the leg. When you're doubling a radical expression, the easiest way to do it is double this outside number. If I double 13, I got 26. So I got 26 root 6 over 3. Alright, now to get H, I got Pythagorean theorem again. So 21 squared plus H squared equals 26 root 6 over 3 squared. Alright, 21 squared is 441. 26 root 6. So if I square the 26 and multiply that times 6, I would have 4,056 over 9. I would then subtract the 441. And H squared would be 9 2/3. I myself would do 29 thirds. H then equals the square root of 29 thirds. Alright, which is the square root of 29 over the square root of 3, which I'm done rationalizing would be the square root of 87 over 3. You're not going to have something that complicated on the quiz, so don't worry about that. But I would expect you to be able to do everything through G. Alright, now the second thing we did today in class, we went over the last problem from yesterday's challenge problems. We've got to clean it up a little bit. Now, yesterday we realized x plus 2x plus 3x equals 180. So 6x equals 180 and x equals 30. So when I plug that in, this would be 30, 60, 90. So it's a 30, 60, 90 right triangle. And down here, since that's x as well, that would be 30 root 5. Like we talked about in the previous problem, 30 root 5 is the, I'm going to call this z to change the variables. So this is no longer there. So z root 3, because this is the x root 3 side, is 30 root 5. To get rid of a multiplication by root 3, you divide by root 3. Z equals 30 root 5 over root 3. I would then rationalize the denominator. So I multiply by root 3 over root 3. I got 30 root 15 over 3. 3 goes into 30, so that's 10 root 15. So that means this side is 10 root 15. Hypotenuse is double that, double 10, I got 20, so I got 20 root 15. So those are my three sides. To get the perimeter, I add all my sides up. Since these are like radicals, I can add those. 20 plus 10 is 30.